Okay, this is solving logarithmic equations. So starting off with the property of equality, it says if b, x, and y are positive real numbers with b not equal to 1, then log base b of x is equal to log base b of y if and only if x equals y. So this is stating that if our bases match, we can cancel them out and we're left with whatever is next to the log. So in the example, we have if log base 2 of x is equal to log base 2 of 7, the log base 2 matches, and so we're left with x is equal to 7. It's also important to note the inverse property, which looks similar to the identity property, that if our bases match on the exponential and the log, they cancel out and we're left with just x. So here are the steps to solve logarithmic equations. There's 3 important things here. One is that if we were to rewrite the problem and we have 2 logs, okay, which means we have a log on one side and a log on the other, we would use the equality property to cancel out the similar logs. Or if we had 1 log, so there's only 1 log on one side, we would change it to exponential form. What's different between logarithmic and exponential is that we have to check for extraneous solutions because log cannot be negative or 0. So once we get an answer, we must check it in order to determine if that is the correct answer. So number 1, notice how we have natural log on both sides. They're exactly the same, so I can cancel them out. So I have 4x minus 7 is equal to x plus 5. I solve for x. Minus x, so 3x minus 7 is equal to 5. Add 7, 3x is equal to 12. Divide by 3, x is equal to 4. And then I check. So I look at the parentheses for both. So I have 4x minus 7 and x plus 5, and I'm going to plug 4 into them. I'm trying to check and see if I get a negative or a 0. So 4 times 4 minus 7 is 16 minus 7, which is 9. That's good. 4 plus 5 is 9, which is good. So x equals to 4 is a correct answer. Number 2. Notice I have log base 4 and log base 4 on the other side. They're the same, so I can cancel them out. So 3x plus 4 is equal to 2x squared plus 4x plus 1. Since I have an x squared, I know it must equal to 0, so I'm going to move over the 3x and the 4. So I have 2x squared plus x minus 3 equals 0. Now I have to do the AC method, so 2 numbers that multiply to negative 6 but add to 1. Would be 3 and negative 2, right? 3 and negative 2, yes. Okay, so that's 2x squared minus 2x plus 3x minus 3 equals 0. I do factor by grouping and take out a GCF, so I can take out a 2x, I'm left with x minus 1. And then take out a 3, and I'm left with x minus 1 equals 0. So that means I have 2x plus 3 times x minus 1 is equal to 0, which means I can set them separately equal to 0, and I get 2x plus 3 equals 0, which means that x is equal to negative 3 halves, and x minus 1 equals 0, which means x is equal to 1. Now I have to check both of those, so give me a minute. I need to move these over a little bit. Okay, so check. So I'm first checking 3x plus 4. Well, let's check the negative 3 halves. Well, 3 times negative 3 halves plus 4 is negative 9 halves plus 8 halves, which is negative 1 half. Well, that doesn't work, so it's not negative 3 halves. Now let's check 1. 3 times 1 plus 4 is 7. That's good. 2 times 1 squared plus 4 times 1 plus 1 equals 7. So that's good. So our answer is x equals 1 because I had to check it in both logs. Now I have number 3, and notice I only have 1 log. And if I only have one log, I have to turn this into exponential. So I'm going to circle my base 2, loop around, and point to my parentheses. So this is the same as saying 2 cubed is equal to 5x minus 17. Well, 2 cubed is 8, so 8 is equal to 5x minus 17. Add 17, so 25 is equal to 5x. Divide by 5, x is equal to 5. Now I check. 5 times 5 minus 17 is 25 minus 17, which is 8. So that is good. Number 4. So number 4, we now have natural log. We need to remember that the natural log of x cancels e to the x. And that since we have e to the x, if we are going to cancel it with the e, we have to know that if we take e of both sides, whatever is on both sides becomes our new exponent. So this would be e to the natural log of 4x minus 1 is equal to e to the third power. Well, the e and natural log cancel, so I'm left with 4x minus 1 equals e cubed. And remember, e, 2.71 repeating, is just a number. So if I'm solving for x, I can add 1 to the other side and then divide by 4. So 4x is equal to e cubed plus 1, and x is equal to e cubed plus 1, all divided by 4. And if I was to put that in my calculator, I would get x is approximately 5,271. Okay. Well, let's check that. Okay. Check. So 4x minus 1. 4 times 5,271 minus 1. Well, that's about 20,000 minus 1. I think we're good there. Okay, number 5, notice how we have 2 logs on the same side. So we need to condense this using the property of logs. Well, since this is being added, we know that this is the product property. Remember, the product property states that if we have log of x plus log of y, that's the same as saying log of x times y. So I can rewrite this as log of 2x times x minus 5 is equal to 2. And remember, if I don't see a base, I know my base is 10. So now that there's only one log, I can circle the base, loop around, and point to the parentheses to turn this into exponential form. So this is 10 to the second power is equal to 2x times x minus 5. So this is 100 is equal to 2x squared minus 10x. Move the 100 over. 2x squared minus 10x minus 100 is equal to 0. I can take out a GCF of 2. So I'm left with x squared minus 5x minus 50 equals 0. And then I need 2 numbers that multiply to negative 50 but add to negative 5. And that is going to be negative 10 and a positive 5. So then I rewrite this as 2 times x minus 10 times x plus 5 is equal to 0, which means x is equal to 10 and x is equal to negative 5. Then I need to check my work. So I'm going to plug it into 2x and to x minus 5. Well, 2 times 10 is equal to 20, so that's good. But 2 times negative 5 is equal to negative 10. That's bad, so it's not this one. And then 10 minus 5 is equal to 5, which is good. So that means my answer is x equals 10. Number 6. Okay, again, we have 2 logs on one side, so I have to use the product property to condense them. So then this becomes log base 4 of 4x minus 2 is equal to log base 4 of x minus 3 times x minus 2. Log base 4 match, so I have 4x minus 2 is equal to x minus 3 times x minus 2. Then I need to FOIL, so I have 4x minus 2 is equal to x squared minus 2x minus 3x plus 6. And since I have that x squared, I need to move everything to one side so it's all equal to 0. So this is x squared minus 9x plus 8 equals 0. So I need two numbers that multiply to 8 but add to negative 9, and that is going to be negative 1 and negative 8. So I have x minus 1, x minus 8 is equal to 0. So x is equal to 1 and x is equal to 8. Okay. Then I need to check. So I have 4x minus 2. So let's check 1. So 4 times 1 minus 2 is equal to 2. That's good. Let's check 8. 4 times 8 minus 2 is equal to 30. That's good. Okay, now let's check x minus 3. Well, 1 minus 3 is equal to negative 2. That's bad, so it's not. X is equal to 1. And then 8 minus 3 is equal to 5. That's good. And I still have to check x minus 2. So 8 minus 2 is equal to 6, which is good. So x is equal to 8. Okay. Number 7. Okay, so again, notice we have two logs on one side, so we need to condense them, but this time we have a subtraction. So this is now using the quotient property, which states if we have log of x minus log of y, that's the same as saying log of x divided by y. So we have log base 2 of x plus 5 divided by 2x minus 1 is equal to 5. I'm going to turn this into exponential by circling the base 2, looping around, and pointing to the parentheses. So this is 2 to the 5th power is equal to x plus 5 divided by 2x minus 1. I'm then going to multiply both sides by the denominator of 2x minus 1 to cancel it out so we no longer have a fraction. So I have 32 times 2x minus 1 is equal to x plus 5. Distribute the 32, so 64x minus 32 is equal to x plus 5. Subtract the x, so 63x, and add the 32 is equal to 37. Divide by 63, so x is equal to 37 over 63. Okay. You would then check that by plugging it into x plus 5 and 2x minus 1. And you would notice that you would not get a 0 and you would not get a negative number, so this is our answer. Okay. Number 8, we have one log on the one side, so I'm going to turn this into exponential. So this is 3 cubed is equal to x squared minus 6x. So 27 is equal to x squared minus 6x. Move the 27 over, x squared minus 6x minus 27 is equal to 0. Then I need two numbers that multiply to negative 27 but add to negative 6, and that's going to be negative 9 and a positive 3. So x minus 9 and x plus 3 equals 0. X is equal to 9, x is equal to negative 3. Now I check. And I just have to check that x squared minus 6x. So 9 squared minus 6 times 9 is 81 minus 56. That's good. Negative 3 squared minus 6 times negative 3 is 9 plus 18. That's good. So now we have two answers for number 8. Number 9. Okay, again, notice we have two logs on one side, so we're going to have to condense them using the product property because of this plus sign here, which means we need to multiply. So log base 8 of x times x plus 6 is equal to log base 8 of 5x plus 12. Log base 8 matches on both sides, so I'm left with x times x plus 6 is equal to 5x plus 12. Distribute the x, so x squared plus 6x is equal to 5x plus 12. I'm going to move these over to the other side so I can get it equal to 0. So x squared plus x minus 12 is equal to 0. So I need two numbers that multiply to negative 12 but add to 1. Those two numbers would be 4 and negative 3. So I have x plus 4, x minus 3 equals 0. So x is equal to negative 4 and x is equal to 3. Then I check. And I check with x, x plus 6 and 5x plus 12. So for x, well, that's negative 4 and that one's 3. That doesn't work and that's okay. So cross off x equals negative 4. Now I'm still checking x equals 3. 3 plus 6 equals 9. Good. 5 times 3 plus 12 is 15 plus 12. That's good. So our answer is x equals 3. Number 10, before we can do anything, we need to make sure our natural log is by itself. So first I need to divide both sides by 2. I get natural log of 4x minus 9 is equal to 10. And then I raise both sides to the power of, I take e of both sides, which means those now become the exponents. E of the natural log cancel out, and I'm left with 4x minus 9 is equal e to the 10th power. I'm going to add 9 to the other side, so 4x is equal to e to the 10th power plus 9, and then I'm going to divide by 4. So x is equal to e to the 10th power plus 9 divided by 4. And if I wanted to get an approximation of this, I would plug this into my calculator, and I would get x is approximately 5,508.87. And then lastly, number 11. I want to get the I want to get the natural log of x by itself. So notice that there's a negative 4 in the front that's being multiplied and a plus 7 at the end. So I'm first going to subtract the 7, and I have negative 4 natural log of x is equal to negative 1. And then divide both sides by negative 4, and I have natural log of x is equal to 1/4. I'm then going to take the e of both sides, which means the e and natural log cancel out, and I'm left with x is equal to e to the 1/4 power. And if I wanted an approximation, I would put that into my calculator, and I get x is approximately 1.284. And notice for number 10 and number 11, I didn't check because these ones are a little bit more obvious, okay? So for number 10, if I was to plug 5,000 into 4x minus 9, well, 4 times 5,000 is 20,000. 20,000 minus 9, I think we're good. Same with 1.284. If I was to plug that into x, well, 1.284 itself is not 0 and not negative, so we're good.